Is menopause wrecking your metabolism? Ketones can help. During menopause, lower estrogen can slow brain function, increase fat storage, cause inflammation, and even lead to insulin resistance. But ketones, especially beta-hydroxybutyrate, step in to fuel your brain, protect muscle, restore mitochondria, and reduce inflammation. They provide clean energy when estrogen stops supporting your cells like it used to. Studies show that ketogenic diets and fasting can naturally raise ketone levels and support better metabolic health through menopause. This is lecture 108 of the Metabolic Classroom. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more. Welcome to the Metabolic Classroom. I'm Benjamin Bikman, a biomedical scientist and professor of cell biology. This podcast, as you know, examines the science of metabolism to provide evidence-based insights for you to just have a healthier life. Today, we are addressing menopause, a phase marked by the decline of estrogen, or more precisely, estrogens. Estrogen is often just used as a term that actually encompasses a few of these more famous female sex hormones. And the most famous, or the primary of all of them, is estradiol. So if you ever hear someone talk about estrogen, or even if I may say estrogen, you could really think more precisely that it would be the hormone estradiol. And it's a relevant thing to mention estradiol because it regulates a shocking number of cellular events, including several related to metabolic health, such as brain glucose metabolism, muscle protein synthesis, mitochondrial function, adipose tissue distribution, and even size of fat cells, and inflammation. So suffice it to say, with all of these benefits in mind, when estradiol starts to drop, like it does during menopause, you do start to see consequences with cognitive impairment, muscle loss, energy deficits, some shifting in fat with more visceral fat accumulation, and even increased inflammation. And so there's an increased risk of many chronic diseases like heart disease and type 2 diabetes. Now, this isn't meant to be a lecture on menopause per se. That's something I've discussed previously, the metabolism of menopause. But rather, I wanted to spend time talking about how ketones might play a role in this unique metabolic state. After all, research suggests ketones, particularly beta-hydroxybutyrate, may mitigate many of these effects by acting as both an alternative energy substrate and a signaling molecule at the cells. So during the time we spend together, we'll analyze some of the mechanistic impacts of menopause. And I wanted to particularly focus on 5 systems that are obviously metabolic in what they have in common. That's the brain, muscles, mitochondria, fat tissue, and inflammation. And we'll detail how estrogen loss disrupts these processes and how ketones might be able to intervene and mitigate some of the consequences. And at the end, I'll have a bit of a dedicated application section, particularly talking about the potential role of exogenous ketones. But ultimately, my hope is that you leave this with a better understanding of menopause's metabolic effects and how ketones may have some potential in addressing them. Now, let's start at the top. And by that, I mean the top of the body. Let's start at the brain. No, and not the top of your body being your hair follicles. What do I have to say about that, after all? But the brain. Menopause does, in fact, lead to impaired brain function because of the drop in estradiol. It is surprising the number of effects estradiol has on the brain. It enhances glucose uptake into neurons by upregulating some of these glucose transporters and even some of the key glycolytic enzymes, or the enzymes involved in becoming proteins that help burning the glucose for fuel. But all of this is what the brain uses to increase ATP production in regions involved in memory and learning, like the hippocampus. Estradiol also stimulates neurotrophic factors that promote neuronal survival and synaptic plasticity. So those are 2 key features of just keeping a healthy brain. Additionally, it doesn't end there. Estradiol even modulates neurotransmitters, which can help with mood and attention. And then, of course, as estrogens fall, glucose metabolism is compromised. as we're going to get to, oxidative stress increases because of the mitochondria, and there's even some neuroinflammation. All of this is going to contribute to problems with memory and mood. Now, where does the ketone come in? Beta-hydroxybutyrate may counteract some of these effects. Probably more than any other tissue in the body, the brain responds favorably to ketones. Beta-hydroxybutyrate, or BHB, crosses the blood-brain barrier. And now, why do I even mention BHB? Because that is the main form of ketones in the body and in the blood. And when it's in the blood, it will readily come across the blood-brain barrier. And when it gets into the neurons of the brain, like it would in any cell, it gets metabolized to acetyl-CoA. And acetyl-CoA then feeds into the citrate cycle, or the citric acid cycle, or the Krebs cycle. It's all the same thing. I call it citrate cycle, which is an excellent source of ATP, the main currency of getting work done in the cell. And research has shown that BHB enhances neuroplasticity by promoting gene expression through epigenetic mechanisms, meaning it's not changing the gene, but rather the degree to which the gene can undergo transcription to become a protein. That's what is involved with that epigenetic mechanism. But BHB also reduces neuroinflammation by inhibiting microglial activation. Those are some resident immune or inflammatory cells. And it can thereby lower pro-inflammatory cytokines. Evidence from ketogenic diet studies in neurological conditions suggests BHB can stabilize cerebral energy metabolism, offering potential benefits for cognitive health during menopause. Because remember, that's the point of this. So just to reiterate, as the brain starts to suffer in the absence of estradiol, ketones may be able to step in and help rescue or maintain some of those functions that may be suffering as estradiol starts to wane. Now let's go from brain into brawn, the muscles. Estradiol plays a surprising role in maintaining skeletal muscle mass and function. It's just important to highlight that when we talk about sex hormones, we overwhelmingly focus on androgens like testosterone. But most people don't appreciate the fact that even estrogens, and the main one, estradiol, actually have a very relevant role, where in particular, estradiol can modulate something called the insulin-like growth factor 1 pathway, IGF-1. And when IGF-1 is turned on, a muscle undergoes hypertrophy. Also, through estrogen receptor alpha, estradiol increases IGF-1 expression and receptor sensitivity. So not only is there more IGF-1, but it's enhancing the reception to IGF-1, all of which is going to promote an anabolic signal or a muscle building signal and reducing muscle protein breakdown. So think about the muscle with both an input, the stimulus for muscle protein synthesis, which estradiol helps with. Then there's this output, which is a process called proteolysis, or the breakdown of the muscle. Well, estrogens and estradiol step in for both. In fact, even further, estradiol is known to suppress the expression of things called atrogenes. And you hear in that term atrophy, or atrophy rather. Atrophy. So those are genes involved in muscle degradation. So the combined effects help preserve muscle protein content, and then, as we'll get into, the mitochondria and that helps serve those muscles. Now, let's talk about beta-hydroxybutyrate, because with the loss of estradiol comes the loss of those muscle protective effects that I just outlined from estradiol. Beta-hydroxybutyrate may help preserve muscle mass by enhancing the functionality of the mitochondria and stabilizing the protein synthesis. Research has shown that ketogenic diets improve muscle metabolism and reduce protein degradation. Now, as evidence of this, a recent report used exogenous ketone supplements and found, in fact, this was a ketone electrolyte, where it's BHB coupled to an electrolyte like potassium or magnesium or calcium. But they found that this exogenous ketone could help preserve muscle protein by reducing the circulating levels of branched chain amino acids. These are things like the ones being isoleucine, leucine, and valine. So the branched chain amino acids are probably something you've heard of. And pardon a brief tangent here. Why would someone take branched chain amino acids? Why even measure branched chain amino acids like I just mentioned? It's because those are the main amino acids in the muscle. And so when you have more muscle breakdown, you have more BCAAs, or branched chain amino acids, in your plasma. Well, in this experimental model, when they were getting more exogenous ketones, there was less. There was a significant reduction in plasma BCAAs, which is going to be a function of reduced proteolysis. In other words, reduced breakdown. So the reduction likely reflects a decreased muscle protein breakdown and the improved retention of those proteins within the muscle. Now, to my great delight, and even greater delight, I'll be able to do this again in a moment, I can highlight work from my own lab. Because just within the past few years, my lab published a report finding that BHB elicits very favorable adaptations within skeletal muscle. And we did this by looking at isolated muscle cells and in whole animals, where BHB improved mitochondrial respiration, where it resulted in a more tightly coupled mitochondria, which is going to be in stark contrast to what happens at the fat tissue in a favorable way. But in other words, the mitochondria are making sure that they're working better. They're more efficient in the muscle. There's less waste of energy within the muscle. We also found that there was a much greater degree of mitochondrial fusion, and that was likely the mechanism that explained why the mitochondria appeared to be working better, if you will, where they were burning fuel to create more ATP, which for an ATP-hungry tissue like the muscle, that's a very favorable change. So once again, like it was with the brain, we can see that some of the loss that is experienced with the loss of estradiol at the level of the muscle could somewhat be preserved with ketones. All right, now let's shift away from tissue for a moment and go into the cells before we actually go back out to tissue level in just a moment. But with brain and mitochondria, what they have in common is a tremendous reliance. With brain and muscle, what they have in common is a tremendous reliance on mitochondria. Mitochondria are central, indeed essential to energy production within a cell. And estradiol plays a key role in maintaining mitochondrial function. In particular, estradiol promotes mitochondrial biogenesis, so the synthesis of new mitochondria, by upregulating a master switch here within the cell called PGC1 alpha. And it will increase the even replication of the DNA within the mitochondria, which facilitates them dividing. And it also, estradiol, enhances antioxidant defenses by activating an enzyme called NRF2, nuclear respiratory factor 2, NRF2, which in turn upregulates enzymes like superoxide dismutase, SOD. And that is one of the more powerful enzymes within a cell to squelch or remove oxidative stress molecules. Then during menopause, all of these protective effects are diminished, leading to reduced mitochondrial density. There's less biogenesis, there's more fracturing, increased ROS production, impaired ATP production. And now, at the level of the cell, that's what's happening. But as you step out from that level to the whole body, this could be some of the fatigue that a woman may notice from post or current menopause to premenopause, where she's just more winded more easily. But what's the role for BHB here, or ketones? Well, beta-hydroxybutyrate can help restore some mitochondrial health. After all, BHB activates PGC1 alpha, albeit in a different mechanism than estradiol does. But the net effect, or the end effect, is going to be the same, where while estradiol stimulates mitochondrial biogenesis through its mechanisms, BHB will through its own. So there is an increased mitochondrial biogenesis with BHB. In BHB also, ketones also enhance fatty acid oxidation, where if you're burning more fat, it just helps stabilize, if you will, energy demands in the body, rather than the individual being subject to the highs and lows of glucose, and there is no nutrient that is as volatile as glucose can be. If you can help the body be burning fat more consistently, it can help stabilize some of this energy. Furthermore, ketones can reduce oxidative stress by once again upregulating NRF2, NRF2, and then the subsequent antioxidant enzymes that are going to be boosted as a result of that increase. But these effects collectively will improve the viability and the population of the mitochondria and even their resilience which is altogether going to support cellular energy demands, including in the brain. So let me just make that connection again back to the brain earlier, that absolutely part of the cognitive decline that a woman is going to experience with the loss of estradiol in menopause is going to be because of the reduction in mitochondrial content or population and function. BHB directly challenges that or fights it and has its own beneficial effect at maintaining the mitochondria in a way we want them to be working. All right, now let's go to the next tissue, a favorite of mine, which is fat tissue. So we were tissue, then mitochondria, now back to the tissue level. Estradiol actually has a tremendous effect on fat within the body, most especially fat distribution, but also the way we store fat. Estradiol actually has a limiting effect on visceral fat depot. So to say that again, we're the human, or in a different way, humans, we generally have two fat depots. We have subcutaneous fat, which is a very healthy place to store fat, and then visceral fat, which is a less healthy place. Well, estradiol helps that storage be more subcutaneous. And so there's this protective effect at reducing the potential for visceral fat depot or deposition. But menopause, of course, with the loss of estradiol, is going to shift that. You also lose the protective effect of promoting more hyperplasia than hypertrophy. So when a woman goes through menopause, where the estradiol levels come down, her fat cells are now going to start getting bigger as her fat cell number will start to wane. Remember, it's not the mass of fat that matters most when it comes to fat and metabolic health. It's the size of each fat cell. And in that regard, estradiol helps. Now, when estradiol goes away, thankfully, ketones are among perhaps a number of things that can also help. Research from my lab has demonstrated that beta-hydroxybutyrate significantly influences mitochondrial function, particularly in adipose tissue. Now, what I found in the muscle was that the ketones made the muscle more efficient with its mitochondria and its use of energy. So we would say, as I've explained previously, there's a greater degree of mitochondrial coupling, the degree to which the mitochondria are burning nutrients in order to create ATP. The more you're burning only what you need for ATP production, the more coupled, we would say, the mitochondria are. However, as I'll outline here, what we find is more mitochondrial uncoupling. So one of the two studies that I'm referring to that we published from my lab, it was an incredible study, and it's one of the ones I'm most proud of. We looked at isolated fat cells, we looked at fat tissue from rodents, and even fat tissue from humans. So we had all three commonly used biomedical models. And we found that when ketones were up, either in the cell culture or in the animals and humans, that the mitochondrial respiration, or the rate at which the mitochondria were breathing, or the metabolic rate of the cell, if you will, in the fat tissue went up by more than double, including in the humans. In fact, in the humans, if I recall, it went up to almost triple. Now, this did not have a corresponding increase in ATP production. So this indicates what I was just explaining, this increase in mitochondrial uncoupling, where now you have mitochondria that are chewing through, they're burning nutrients, it's burning fats, it's burning glucose, just to waste it as heat. That's actually a very favorable adaptation. Moreover, we found that the gene expression revealed an upregulation of a lot of these proteins, not only involved in mitochondrial biogenesis, like PGC1 alpha, one that I just mentioned, but also uncoupling proteins, and the most relevant being UCP1, uncoupling protein 1. Now, just to sort of finish and round out this story, and maybe just to highlight some of my own work, don't hold it against me, I'm quite proud of it. We actually published another report looking at how elevated insulin suppresses mitochondrial in adipose tissue. It suppresses mitochondrial uncoupling. So insulin forces the metabolic rate and the coupling status of the mitochondria in the fat tissue to be tighter or more miserly. So in other words, maybe to bring this back to menopause, a gal who's going through menopause with the loss of estradiol and its protective effects at fat tissue, if she combines that metabolic mayhem and exacerbates it by eating a diet that is keeping her in a state of chronically elevated insulin, that is an absolute recipe for disaster. So one way to transition well into menopause and to thrive, perhaps, would be to help take advantage of these dual phenomena that we noticed. One, lowering the insulin to remove that inhibiting effect which allows the mitochondria to burn faster and hotter in the fat tissue, but then to complement this by also starting to make more ketones, which you will, after all, when insulin is down. So all of this, once again, just highlights another potential mechanism by which ketones can counteract some of the insulin-driven, not only insulin-driven adiposity, I have a hard time not invoking insulin, but also the consequences of estradiol dropping. Okay, now let's get into inflammation, which is neither tissue nor cell specific. This is a whole body phenomenon. Estradiol has very relevant and powerful anti-inflammatory effects, and by suppressing some key inflammatory pathways. And we can see this even in real time with estradiol therapies. Menopause, of course, removes this regulation, which is a favorable regulation in its origins, but it leads to an increase in systemic inflammation and thus a higher risk of diseases that are associated with it. Now, what about ketones? Well, even here, ketones really shine. Beta-hydroxybutyrate has been shown to inhibit inflammatory pathways, particularly a ringleader here, which is called the NLRP3 inflammasome. And the inflammasome is a key master regulator that when it is turned on, pro-inflammatory cytokines are turned on. So by inhibiting the NLRP3 inflammasome, it's no surprise that there's evidence to show that BHB reduces the expression of pro-inflammatory genes, which can help just regulate this systemic inflammatory state. And so the anti-inflammatory effects could help counteract some of the inflammation that's associated with menopause. Now, once again, and finally, I can highlight another study from my lab, as over the past few years, we've really devoted some means and time to understanding ketones. And we found that ketones can mitigate the inflammatory and metabolic consequences of elevated uric acid. Now you're saying, whoa, why are we even bringing in uric acid? This isn't a conversation about gout. No, it's not, of course. But uric acid is known to powerfully activate the NLRP3 inflammasome and to promote significant inflammation. What we did was treat cells with uric acid, and then we detected a significant increase in the expression of pro-inflammatory cytokines. But when we co-incubated these cells with BHB, we blocked it completely. We failed to see this uric acid-induced activation of inflammation. And it also helped the cells just be more viable and robust, despite the presence of the uric acid. We found the mitochondria were working well, oxidative stress was under control, and again, inflammation was down. So these findings just add to all of it that BHB not only acts as an anti-inflammatory agent, but also can protect the mitochondria and the insulin signaling, all of which we measured, even in a pro-inflammatory state. All of which is relevant back to menopause, where you have the loss of estradiol, you have the loss of an anti-inflammatory signal, and thus, no surprise, inflammation tends to go up. But here, BHB could step in to intervene and mitigate some of those effects. Okay, now, perhaps to a degree, although it's not my intention, I've convinced you that beta-hydroxybutyrate is favorable. So let's get into some application of some of these ideas. First and foremost, of course, a woman could consider just adopting a low carbohydrate ketogenic diet. So where dietary carbohydrate has been brought down to a sufficient degree to bring down her fasting insulin. And when insulin goes down, ketogenesis turns on, and now she's making ketones from all the fat she's burning. So that would be the traditional low-carb diet. Perfectly good, and I am an advocate of an individual considering that view. Now, however, a person may think, well, I want the benefits of ketones without the restriction. Well, as much as it somewhat pains me to say, because I'm such an advocate of just changing being tough, but I'm also practical enough to appreciate the fact, and indeed even use this myself from sometimes, but there's absolutely a role for exogenous ketones, particularly given the strictness of a ketogenic diet. All right, let's just go through them. The first one I mentioned a moment ago because most of the studies I mentioned actually use it this way, which is the ketone electrolytes. Now, these are all sometimes called ketone salts. That's a perfectly accurate term. I just kind of prefer the term ketone electrolytes because some people may be worried about salt when I don't think that's entirely justified, when they're not worried about electrolytes, which are just salts. So with the ketone electrolytes, those are beta-hydroxybutyrate molecules bound to minerals, like I mentioned earlier, sodium, potassium, calcium, magnesium. They're generally quite affordable and very accessible. They're much more common. It won't boost your ketone levels quite as high as the next ones I'll mention. Next one being ketone esters. They're certainly more potent and more rapid. But the ketone esters they don't come actually as a ketone. What you're drinking is not ketones, but a precursor. And so the liver needs to convert that. So it's going to be a little longer, but it will work. And of course, it's going to have a pretty significant taste to it. All right, now the last one is actually the newest. The newest form of exogenous ketones is the beta-hydroxybutyrate. Sometimes it's just called the acid. But this is just straight, it's a bioidentical, naturally occurring version of the ketone. And so you drink it in and it's just straight BHB. It will raise ketone levels very effectively and efficiently without any sort of electrolyte or without, the need to convert it in the liver. And it does come in two forms nowadays. There's the DBHB, which is the more identical form to what we mostly have, but we also do make a little bit of what's called LBHB, which is the kind of mirror chemical image of it. And it is increasingly making its way into supplements. We do make it. The liver will convert some of it into the DBHB, but it also, some emerging very early evidence suggests that LBHB could have some distinct signaling effects, particularly in the brain. And given that the brain is one of the tissues very susceptible to menopause, maybe LBHB will prove to be more than just some passive ketone byproduct. Now, of course, I ought to talk about MCTs, medium chain triglycerides or medium chain fats. Remember something I've articulated previously, the shorter a fat gets, the more it can only be burned. Whereas long chain fats can be stored very readily, but also burned. The shorter the fat starts to get, like the medium and the short chain fats, the more they're just going to be burned. And the more you're burning fat, the more you're making ketones. So MCTs can not only be burned quickly, but also absorbed quickly. And they're taken right into the liver. They don't have to go through the normal process of absorption through the lymph like longer chain fats do, but they get readily absorbed, readily taken into the liver, and then readily burned by the liver. And the more readily a liver is burning fat, the more readily it's turning that into ketones. Let's wrap it up. Now, I believe if you needed any convincing, hopefully I've done it. So menopause really does introduce a very meaningful metabolic challenge into the life of a woman. And that loss, that decline in estradiol will affect brain, muscle, fat, mitochondria, and inflammation. And ketones, mostly beta-hydroxybutyrate, also affects all of them in a way that is somewhat complementary to estradiol. Thus, when estradiol starts to wane, perhaps there's some justification for a woman saying, well, all the more reason for me to have my ketones start to wax. In other words, go up. All right, but my hope is by understanding the mechanisms and some of the practical strategies that you could be more armed in weathering the metabolic storm of menopause a little more readily. Thanks for joining me in the Metabolic Classroom today. Please remember, more knowledge, better health. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more.